All right, let's do this. Let's start by going over last night's homework. There were 6 questions. Hopefully you actually put some effort into them and tried them. This first one, the composition of sediments on Earth's surface is quite different from the composition of the underlying bedrock. This observation suggests that. So why would those sediments on the surface be different than the underlying bedrock? Let's review. What is bedrock?
Rocks.
It's all the way in the bottom and it's hard and it's rock. What do you got to do to get to the bedrock? Dig. What are you digging through? Dirt and soil and rocks. What are those things called? Dirt, soil, and rocks? Those are sediments. So this question here is saying, so did you guys get your information from Minecraft?
Yeah.
And that's exactly what I was hoping you were going to say. Do you agree, Phoenix? That's where you got your information from, was Minecraft. So you dig through the sediments and you get to the bedrock. The thing with bedrock, because it's that solid layer of rock that you can't like break through, that's the rock that was like born and raised wherever it is. So if we dig through out here, we dig through all the sediments, we will get to a layer of rocks that this is where they've always lived. They've never been moved. But what about those sediments on top? Like this question is saying they're different than the bedrock underneath them. So were they from here then, if they're different than what is being living here? So are the sediments from around here? If they're different? No, that's an actual question, guys. No, they're not from around here. Those sediments, how'd they get here then? They would have been moved here. So that's answer 4. The sediments have been transported here. So when the sediments, the dirt and the rocks and the gravel you got to dig through are different than the bedrock, it means they came from somewhere else. All right, show of fingers. What's the answer to number 2? I'm seeing most of the right answers. It is erosion. Guys, remember residual? Just kind of like the bedrock. The residual means it hasn't been moved here. Residual means it stayed around. It has not been touched. So the fact that the transported materials are more common than the residual means that erosion took place. Now, most of the surface materials in New York State can be classified as, in most of New York State, we talked about this already. What is our materials? What answer did you pick? Give me a show of fingers again, please. Don't bother looking around, just show me what you wrote down. You got it. It is transported soils. By the way, what has transported most of the soils to New York State? Glaciers. We were known for our glaciers. Most of the northern part of North America was covered in glaciers during the Ice Age. So glaciers brought and shaped almost everything in New York State. Number 4 is similar to that first question. So we've got granite pebbles found on the surface of the area where only sandstone bedrock is exposed. Which is likely the explanation for the presence of these pebbles. So quick review. What is granite? That's an igneous rock. What is sandstone? This is sedimentary. So we've got one type of rock sitting on another type of rock. Why is that? How did that happen? It's because the answer number 1, they were transported from somewhere else. So the igneous does not go with the sedimentary. So it must have been brought here by something else. Number 5, the process. Ooh, this is a good one. Remember how I keep telling you, you got to know the difference between weathering, erosion, and deposition. So we have rocks broken up and rocks moved to different locations. Which words represent breaking up and moving? What answer is it? Phoenix, what you got for number 5?
Number 5, I chose 3.
3, burial and sedimentation is when rocks are broken and moved? No. You meant to. Good, because that's the right answer. Weathering is the breaking. Erosion is the moving. And then finally 6, transported materials are more common than residual materials in the soil of New York State. This statement best explains this observation. Which one do you pick? This one involved a little bit of reading. Again, see a show of fingers. You need to reread it. Go ahead and check that out. I'm seeing 3 as most of your answers, and that is correct. Most rock material was moved or eroded at one point in their history. It's looking pretty good. Between yesterday's review and this, I'm really impressed with how you guys are doing. We're going to skip pages. Oh no, actually we never finished. We gotta go back to 14. We did not do horizontal, vertical, or graded bedding, right? Okay, that's right where we gotta go. So give me a second. I do have to pull that PowerPoint up, I think. Nope, yes, because somehow I've got rocks and minerals open.
Oh.
Whoops, wrong one. So we finished up here with sorting and unsorted sediments. So what we need, right? You guys got this sorted and unsorted? Okay, good. So we're gonna talk about how different sediments can be sorted. Now, I want to tell you a quick little, I need you guys to picture something right now. So it's not a story. I need you to use your imagination. Got this? Phoenix, you got imagination? Ready to use it? Can you, instead of picturing it being cold and disgusting out right now, it needs to be a beautiful summer day and you're headed to Darien Lake.
Oh, yeah.
Okay, hopefully you're a fan of the water slides because that's where you're going. No? Okay. Well, here I need you to picture, it doesn't have to be a Darien Lake scary water slide. It can just be a small water slide. So water slide to me reminds me of a river. So we got the slide itself is like a river because rivers go downhill, right? Like a water slide. Now, most of them aren't quite as eventful as a water slide, but rivers flow downhill just like a water slide. And when you're on a water slide, when do you get deposited? If you're the sediment, where? At the bottom. You get dropped off at the bottom of a water slide, last I checked. What? Well, okay, work with me here, would you? Gotta be perfect conditions. So at the bottom of the water slide, you get deposited. Now, does every single human get deposited in the exact same spot in the pool at the bottom of the water slide? It depends. So the answer is no, and then it depends. What does it depend on? How fast they're going and what is going to control how fast that human is going down the water slide. Okay, one could be the water, their size. So your size is really going to control, because everybody, hopefully the water slide's going the same for everybody. Same amount of water, same slope, same everything for the water slide. So the water slide's the same. The only thing that changes are the people. So this goes back to a story of my daughter. She was really little and she was really afraid to go down her very first water slide. So she asked my husband, can you go down? She wanted to watch it. So my husband, a full-size, normal-sized adult, goes down it's just at a hotel. It's a really dinky water slide. And he goes up the stairs, goes 1, 2, 3 loops around, and he's an adult. He just goes kerplunk at the end of the water slide. Not very eventful. Mallory looks at that and goes, I can do it. Mallory it was quite a while ago. She was really small, maybe like 35 pounds soaking wet. So not anywhere near the size of my husband. What do you think happens to her when she goes down this? I swear to God, she goes up that water slide. She goes boom, 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 and she skips across the pool. Exactly like Sam described. Why did she skip across the pool when my husband just went kerplunk?
Because she's lighter.
Because she's lighter. She's real little. Now, if we were able to send like a bunch of sediments, a bunch of Mallory's and a bunch of my husband's and maybe a bunch of you guys down, would you all land in the exact same spot they did? No, it's going to be different based on your size. The same is true when a river is carrying sediments. Or imagine taking a box of all different kinds of rocks and sending those down the water slide. Where would they end up in the pool at the bottom? Now, they would all just pile up in one spot?
No, I think.
They would, now notice what, did you guys notice what Sam just did with his hands? He said they'd spread out and he put his hands out in a straight line. That is called horizontal sorting. So horizontal sorting occurs when a stream enters a larger body of water. The velocity of the stream slows down and larger rocks settle out first. That's exactly what Sam just described, that those rocks would be spread out. The bigger ones right near the bottom of the slide, the smaller ones taken out further. You have a picture of this right next to where you're writing. We'll talk about that in 1 second. Okay, so that picture that I'm talking about right here, what do you notice? So we've got the stream, a stream was flowing, enters the lake. And what do you notice about those rocks? Yeah, Chris, what do you see there?
Bigger ones.
Yeah, big, and if you need to label that, big to small. The big rocks get dropped off first, and the tiny ones like Mallory get carried further into the pond or the lake or whatever this is, or the pool if it was a water slide. That's horizontal sorting. So again, not a perfect horizontal line, but going in a line horizontally. Versus the next one is vertical. Which way is vertical? That's up and down. Now there's no picture for this one, but maybe you can squeeze in a little demonstration over here. What would happen with vertical sorting, instead of having like a slow, like first they were going and then it slows down. Yep, they're gonna go up to down. What this is, instead of sending that box of rocks down the slide, I'm just gonna tip the box of rocks into the lake or the pool. This happens during like an avalanche or things like that, where the rocks just tumble into the water. And the same thing, and we're doing it in lab, if you haven't noticed the tube that's there, we are doing it in lab where you got the big rocks on the bottom, medium to tiny to just specks of dust. So that's vertical sorting, if you want to add a picture of that. So we've got big, medium, small, tiny. That's vertical sorting. I'll give you the notes for that in 1 second here. The picture is showing biggest rocks on the bottom, medium, small. You could have done a couple layers of big too if you wanted. All right, here's the notes that go with vertical sorting. Vertical sorting. Sediment, sorting of sediments from the bottom to the top. Largest, roundest, more dense particles settle out first. Happen after a major event like a volcanic eruption or a landslide or an earthquake where rocks fall into the water. All right, and the last one there is graded bedding. No, it's not. Yeah. Graded bedding. This is when you have that vertical sorting, but over and over again. So like one earthquake would have dropped in a bunch of rocks, then it sat there for a while, and then another earthquake might have dropped in a bunch of rocks. And you can count the events by counting how many sets of layers there are. Okay, so that was actually what we should have finished yesterday. We didn't get around to it yesterday. So today we're gonna actually go to today's stuff, which you would think would come on those pages that are next, but we're gonna skip wave erosion for the moment and run into the running water, which is on page 19. Now, the regions, of course, we call it running water erosion, but they often refer to running water as streams. There it is. So what does a stream mean to you? If I said stream, what are you thinking about?
Running water.
Okay, you are? Yeah, that I really, I wouldn't know. If you heard just like if somebody's talking about a stream, what would you be thinking about? Okay, a lot of us would think, so first thing, you guys now think of streaming services. That's not it, but a lot of us think of like a creek or a creek, right? Why do you think that and not a river? Smaller. I'm right there with you. In my mind, a stream is something small. But of course, that's not what the Regents is talking about because that would make life too easy. But it's actually not a hard concept. What they are talking about is legit any moving body of water, any flowing body of water. So right there in the top of page 19, what is a stream? It's any moving body of water. It includes a creek, but it also includes a river or an actual stream. It could include a waterfall or other places. They'll use the word brook. I don't think around here we ever talk about brooks. Just like in other parts of the country, they would never use the word creek or creek. It's kind of like a regional thing. So just anytime they're talking about a flowing body of water, like even a ditch, like a full ditch can act like a little baby river too. Yeah, a drain on a pond, even if you legit like just leave the hose on in your yard, it will behave like a baby stream eventually. So anytime there's running water, even just like a drip from the faucet will eventually erode away the ground just like a waterfall would, just like a river would. Now, I also, like I said a few minutes ago, I like to think of water slides as a river. And the reason I do that is because a lot of us can picture water slides a little bit better than we can picture just like how a river behaves. So let's talk about a water slide. We already established that how fast a river flows is going to control a lot of things. Like the speed of the river will cause there to be more or less erosion. We already talked about that. Faster rivers, more erosion. Slower rivers, more deposition. So what controls the speed of a river? Or if you don't want to think of a river, think of a water slide. What controls how fast that water slide is going? What do you mean by, I know what you mean, but I need you to kind of explain it better. What do you mean by water pressure? Yes, that could be so, but a river, so the difference with the river and the water slide is that a river, I can't just turn up the faucet. So there is something though. When does a river go faster?
All right.
More rain, when there's more water. Same with the water, and that's what you meant by the more water pressure, like on a water slide, if I turn up the amount of water, it's gonna go faster. Again, we can't just turn up the amount of water on a river, but when there is more water because of rain or melting snow, the rivers go faster. So the amount of water is gonna control the speed. Can you think of something else that will control the speed? The slope, yeah. Think of like, what's different between the lazy river and one of those faster water slides at Darien Lake? Okay, the slope down, those really fast ones, I'm not going on them, that's because they're too steep. I'm a wimp. I used to be braver. Something about having kids made me turn into a wimp. Something about like having to like preserve myself to be able to take care of other humans. I think it's called like evolution or something, I don't know. But anyway, moving on. So yeah, the slope of the river, how much water is in the river, and there's actually one more thing. And again, you can think back to the lazy river versus other faster water slides. Or maybe not just the lazy river, but those really fast water slides. I know they actually have in Darien Lake, when you're in the lazy river, there's right off to the side, there is a really fast water slide right across from the lazy river. The racing one. What's different between the racing one and any of the other water slides? It is narrow, there is something else too about it. It's not just plain. That too. Can you picture the shape of it?
So,
The hill, the slope, but isn't it just straight?
yeah.
Just straight versus the other water slides. Yes, they might go faster than the lazy river, but the other ones, once you introduce a curve, it's gonna slow down the speed you're going at. So the curves are gonna slow you down. Same with the river. A straight river is gonna go faster than a curvy river. So you actually did all the notes already, or you said them all, so let's go through the notes. This first one's what Chris said, the slope. But of course, in the Regents world, we can't just use easy to understand words like slope. It's called gradient. That's a good place for it. Perfect, right there. So gradient, guys, we did gradient already this year. Remember chapter 2, the connect the dots for slightly older kids when we had to do math. Change in field value divided by distance. It's coming back to haunt you. Okay, so gradient is really just talking about the slope. The steeper the slope, the faster the water moves. Not rocket science. Everybody got that one? I go to the next slide. Now you said the amount of water, that's what Phoenix was talking about, but we can't again use the words amount. We have to say the volume. Volume is just talking about how much water there is. And of course, here's a new vocab word, discharge. If you're discharged from the hospital, what does that mean? You're free to go. You're free to leave. That's the one I like to talk about. So in this case, it's how much water would be leaving the river. I'm going to Google something real quick while you guys write. Yeah, while you're doing these notes, I'm going to Google something. So discharge is just the amount of water going past a point in a certain period of time. What I just Googled is the discharge of the Niagara River over Niagara Falls. And it says that approximately 75,750 gallons of water go over the American and Bridal Falls every second. 75,750 gallons per second go over those falls. That's the discharge. So how many gallons go over it a second? So that's all that discharge means. It's kind of similar. It's a chain. It's a rate thing. So it's amount per time. Moving on, the last one you guys just told me was channel shape. If it's going to be straight, it's gonna go faster than if it's curvy. And then there's one more vocab word, meander. Ever heard that word used in everyday English, meander or meandering? Kind of. You've heard it. Maybe some of your teachers might say you've been out meandering the halls. Wandering. Kind of works for me. When somebody's wandering the halls, can you describe their motions to me? They're walking slowly. Give me some more descriptors for wandering. Looking around, kind of creeping. Are they going in a straight line?
No.
They're wandering. They're kind of like la di da di da, like this, right? Just you don't want to be walking behind them if you're in a hurry. Kind of going one side of the hall to the other. You know people like this? They just wander. That's meandering is the same idea. It's where you're going to be going curve. Instead of walking a straight line, if you're meandering, you're going side to side. In earth science, a meander is just a curve in the stream. Actually, that's all I want you to write for the moment, a curve in the stream. I'll do it here. We're gonna add to it, but I want to walk through it first. So meander is a curve in a stream. Sorry, a stream. That's two words, not one. Yeah, no, a stream. What problem with putting spaces between my words? We're gonna go ahead and draw a meandering river, but I'm taking away all your creative freedoms and you got to do it like me, okay? So here's what I want. We're gonna use this empty space here. Start it near the bottom. Go do an uphill, a downhill, and then go back up. Then we're gonna just add a second line, so it kind of actually looks like a river. So so hopefully you have an up, then a down, and then go back up. So everybody got this shape? An N and then a U, maybe? All right, so first of all, we got to add some arrows saying that the water is going this way. Well, this is flat, so it's not going up. It's just going north, remember? Up is up. So this is, okay, so just so you know, this is just a nice flat-ish, what? Yes, that's the word I was looking for. This is an overhead view of a river. So it's not really uphill then downhill. It's just like we're standing here looking down at the river. So if the water's going this way, where, first of all, can the water freely go nice and fast? No, it was not a yes or no question. I said, where can the river go the fastest? Where is it free to go fast? Was that what you guys were gonna say? Where it's straighter, the water can go fast. Just like running, like you can go faster going straight, right? You got to slow down a little on the curve. Or if you're a race car, driving a race car, those NASCAR drivers, they got to use the brakes to go around a curve. Now picture this being a water slide. Again, you're going nice and fast on that straightaway. You get to the curve. Where does your body go when you get to the curve? Into the wall. So can you picture that? You're going down this water slide. Where does your body go? It hits the wall. Why does it hit the wall? Okay, you're going really fast. Do you have brakes on a water slide? No. So you go where the water's taking you. So the water doesn't have brakes either. It's going, going, going. It hits the wall. Now, if this was a river, what would that constant hitting on the wall do? It would push it out. What's that word we use? It would erode it away. By the way, this is called the outside curve, or the outside of the curve. So right here is the outside. Can you guys add that label, outside of the curve? And just like Chris said, the water will constantly be banging on that side. And that's where the water is going the fastest. Let's just say fast. Fast water. That says fast. And because the water's going fast, and again, Sam already said it, but can you guys again picture what happens if that water is constantly banging on the edge of the river? It's going to start to wear it away. It's going to start to break it down, start to move it. That's called erosion. We have erosion happen. Erosion happening there. Now, because erosion is carrying away the sediments, what do we know about the depth of the river at this location then? If the sediments are getting carried away, it's getting deeper. So on the outside, the water's going faster, causing more erosion, causing sediments to get carried away. So that's the outside of a curve. There's an inside of the curve. Now, is water still going there? It is still, but it's going slower. I'm going to do, this is an inside here. This is also an inside of a curve. So you do always have to just pay attention. This girl is confused about her study hall. So going down, this is an inside of a curve here too. So you do always have to look at which way the water's going. So this is an inside here. And just like Sam said, it's going slower here. Now, if it's going slower, are we going to have as much erosion? In fact, if it's going slow enough, what's it going to do to those sediments it did pick up? Start depositing them. And we have a vocab word for that. We're going to have more deposition. And because they're getting dropped off and deposited and all of that good stuff, what's the depth of the water going to be? Shallower. So the outside and the inside of a curve behave differently. Now, this is something that I actually think you should pay attention to if you ever are going to buy a house or a property that has a stream near it. So let's say you're going to build a house. Lots of people like to build houses overlooking water. Gives them like some sense of nature and stuff like that. Where do you want to build a house then? On the outside or the inside of a curve? Why not the outside? Why don't you want to build a house right? Because it's going to erode and eat. Yeah, first your yard, then your house. So you do want to build a house or any structure on the outside or on the inside of a curve. You guys probably don't know this because you were too young. It was about 12 years ago. You know, the Cattaraugus Creek, we got Tim Hortons and Class Boys. They actually had to reroute the Cattaraugus Creek there. You know how now it's closer to the Tim Hortons side of the bridge? 12 years, well, I guess 13 years ago, before they fixed it, the creek actually was much closer to the Class Boys side. And what was happening is eating away the backyards of the houses over where Class Boys is. They have since rerouted it, and by putting lots of stones and concrete down there so that it's over and not eating away at the Class Boys side of the hill. So this is something that is legit. They spent thousands and probably millions of dollars to fix that creek so it didn't eat away the Class Boys side of the street. I think this seems like a perfect place to stop. You do too? And I decided no homework today, but be ready, you're gonna have some tomorrow.
That's it.
Says me, I'm in charge, I'm the boss.
Oh.